Hi everyone, in this video we are going to discuss about the condition for two lines to be parallel. So we are going to find out what is the necessary condition for two straight lines to be parallel, right? So in this diagram I have taken two parallel lines, line A and line B, and let's assume that they are parallel. And also let's assume that the equation of line A is actually A sub 1 times x plus B sub 1 times y plus C sub 1 is equal to 0. And similarly, let's also assume that the equation of the line B is actually A sub 2 times x plus B sub 2 times y plus C sub 2 is equal to 0, right? And because the two lines are parallel, can we say that these two angles would be same? I'm now going to highlight the two angles with a yellow arc right here. So if you think about these two lines, they are nothing but corresponding angles between two parallel lines if we assume that x-axis is the transversal in this case. So because the lines are parallel, and if we assume that x-axis is the transversal, then those two angles would be equal. That means you see the angle of inclination for both of the lines is going to be same. So if this angle is theta for line B, this angle will also be theta degree for line A. Now because they have same angle of inclination, their slope would also be equal, right? So if we simply say that what is the slope of the first line, well, I can write it like this. I can say, okay, then slope of the first line would be, I'm using the pink color for the first line. So slope of the line A would be equal to tangent of theta, because that is the angle of inclination of line A. And similarly, what would be the slope of line B? That would also be tangent of its angle of inclination. That is again tangent of theta. So now you see the slope of both lines are actually equal. That means their slope would be equal. So that is one very important concept we have to understand, that if two lines are parallel, then their slope will be equal and their angle of inclination would also be equal. Now with that, let's try to convert the equation of these two lines into the slope-intercept form. So if we convert the first equation, so our equation of the first line is like this: A sub 1 times x plus B sub 1 times y plus C sub 1 is equal to 0. Now I'm going to convert that into the slope-intercept form. So we're going to keep the y term on the left hand side, so it would be B sub 1 times y would be equal to negative of A sub 1 times x and negative of C sub 1. And if we divide both sides by B sub 1, then what are you going to get? Well, on the left hand side we are going to be left with just the y, and that will be equal to negative of A sub 1 divided by B sub 1 times x, and then minus C sub 1 divided by B sub 1. So this is the slope-intercept form of our first equation. Now from here, one thing I would like to highlight, that the slope of this straight line is actually this right here. So this is the negative of A sub 1 divided by B sub 1. That is the slope of this straight line, which is the straight line A, the first one, right? Now let's also do the same thing for the second straight line. So for the second straight line, which is the line B, the equation is like this. So I'm going to write right here. So we have A sub 2 times x plus B sub 2 times y plus C sub 2 is equal to 0. Now from here we are going to do the same exercise. We are going to keep the y term on the left hand side, so it would be B sub 2 times y is equal to negative of A sub 2 times x and minus C sub 2. From here we are going to get, if we divide both sides by B sub 2, what are we going to get? We'll get y on the left hand side, and that will be equal to negative of A sub 2 divided by B sub 2 times x minus C sub 2 divided by B sub 2. So here again, as you can see, the slope of the second line, which is the line B, its slope is now looking like this, which is the negative of A sub 2 divided by B sub 2. That is the slope of the second line. And now we have already discussed and we have already proved that the slope of both the lines are equal. That means the slope of the first line and slope of the second line, they are equal, right? So if they are equal, then this is our necessary condition. So from here, can we say that the slope of the first line line which is negative a sub 1 divided by b sub 1, that is the slope of the first line. And what is the slope of the second line? Well, slope of the second line is actually negative a sub 2 divided by b sub 2. So they must be equal, and I'm going to put an equal sign because we have already proved that their slopes would be equal if they are parallel, right? And in this case our assumption is that both the lines are parallel, so that means their slope would be equal. And then from here what we can do? Well, from here it's pretty easy. Now we are going to multiply both sides by a negative 1, so it will become a sub 1 divided by b sub 1 is equal to a sub 2 divided by b sub 2. And from here, if we bring a sub 2 to the left hand side by transposition, so it would become a sub 1 divided by a sub 2. A sub 2 will come to the denominator, and then we are bringing, let's bring b sub 1 onto the right hand side. So then b sub 1 goes to the numerator and b sub 2 stays in the denominator. So this is our necessary condition for the two lines to be parallel, meaning if we have two parallel lines, then this condition would satisfy. The ratio of the coefficients of x will be equal to the ratio of the coefficients of y. Let's take an example. So suppose we have been given the equations of two straight lines and we have been asked to find out the value of b, which is right here, the value of b if these two straight lines are parallel. So if they are parallel, then what are the necessary conditions? The necessary condition that we know would be like this. So we can say, okay, then a sub 1 divided by a sub 2 would be equal to b sub 1 divided by b sub 2. And in this case, what is a sub 1? So let me write down right here. So this is our a sub 1, and then this positive 3, that is our b sub 1, and similarly this is our a sub 2 and this is our b sub 2. And of course we don't have the c on the left hand side. If we bring them, then this positive 5 will become negative 5, that will become the c sub 1, and then positive 20 will become negative 20, that will become c sub 2. But again, for our condition we don't have c portion. We are only interested about a and b, the coefficients of x and y. So let's not worry about the constant term. So from here what do we get? Can we solve it? So let's solve it from here. So from here we can say, okay, then what is a sub 1? That is positive 2. So positive 2 divided by what is a sub 2? That is actually positive 4. Okay, great. And then that will be equal to what is b sub 1? That is actually positive 3, and divided by what is b sub 2? Well, b sub 2 is actually b, lowercase b. That's the b right there in the second equation. So then from here let's bring b to the left hand side. So then 2 times b, if we simply cross multiply the denominators, then it would be 2 times b equal to 4 times 3, that would be 12. And then from here we can say, okay, then obviously our b is equal to 12 divided by 2, that would be 6. So we get b is equal to 6. So if we have the value of b as 6, then those two lines will be parallel to each other. So the necessary value of b would be 6. So then if we rewrite this equation right here, if we rewrite this equation as 4 times x plus 6 times y is equal to 20, then this equation or this straight line becomes parallel to the first straight line, right? So our necessary condition here is b equals 6, or the value of b is equal to 6. So here we had to find out the value of b, and we have found that the value of b must be 6 for the two lines to be parallel. Let's take another example. So in the second example, suppose we have two equations, meaning equation of two straight lines. The first one says y equals 2x plus 3, and the equation of the second straight line y equals mx plus 10. And let's assume that these two straight lines are parallel, then we have to find out the value of m. Now in this case, you see I have intentionally written the equation, or I have intentionally taken the example where the form of the equation is y equals mx plus c form, which is the slope-intercept form. So it's pretty easy now, because for the first equation you see our slope is 2 right here. This is the value of m for the first straight line, and then for the second straight line, what is the value of the slope? Well, value of m is actually m. I am using the variable m there, right? So because the two straight lines have to be parallel, then their slope must be equal. That means this slope value must be equal. So from here we can say, okay, then 2 must be equal to m. That means m is equal to 2. I hope everything made sense. Thank you for watching. See you in the next video.